right now, we are excited to welcome EVGA's Jacob to answer all our overclocking questions. Welcome, Jacob.
Thanks for having me.
Absolutely. What do you do at EVGA?
So I'm product manager at EVGA, so basically anything that involves new existing products, going to shows as well. I just came back from DreamHack, which was a lot of fun, and then talking to you guys, so thanks for having me.
We're very much like DreamHack. Totally.
Pretty much, yeah.
Exactly the same.
Same.
I know you guys are working on new GPU technology.
Yep.
Tell us more about EVGA's iCX technology. What does it do, and who's it for?
Yeah, sure. So we launched iCX earlier this year across a variety of different graphics cards. Actually, I have a few slides that hopefully we can check out.
Let's pull them up, definitely. We can show this off.
Yeah, talk us through them.
Sure. So iCX technology, again, launched earlier this year. It's on GTX 1060, 1070, 1080, 1080 Ti, even the new GTX 1070 Ti, which just launched today, actually. So basically what we did is we tried to rethink the cooling process on graphics cards. So what we did is we added an additional 9 sensors on the card to detect the temperatures in various different regions of the card. So we're not just relying on the graphics card temperature, we're actually looking at all parts of the card.
Individual components.
Right, yeah, so like memory, VRM. So with those 9 sensors, we're able to detect the temperatures and also adjust the fan speeds. So basically with iCX technology, all of our fans on the card run at different speeds, depending on the region. So basically, every single fan is responsible for cooling a different region. So this is an entirely different way of cooling a graphics card than what was available previously. So in addition to that, you can also monitor all of those sensors from within our software. It's called EVGA Precision XOC. So you can see what your memory temperatures are in real time, or your VRM temperatures, something that has never been available before in a graphics card. Now we can see in real time. In addition to that, I mentioned we have the individual fan curves, or the fan speeds, that spin independently, depending on the region. You can also control these independently. So you can customize the card to your liking. You can set the left fan faster than the right fan, or you can find the best cooling efficiency, depending on what you're looking for. And lastly, with iCX, one of the things that we added is right on top of the card, or actually the side of the card, there is 3 LEDs that will tell you the operating temperature via different colors of the GPU, memory, and power section. So you can see in real time when you're running a game or benchmark or whatever you're doing, you can see exactly what those temperatures are.
That's cool.
And so with iCX, is that also starting to take advantage of, because I'm sure a card like this is going to be going into a system where the builder has probably considered other components, and cooling, I mean, again, one of the things we've talked about last week was sort of considering your PC holistically.
Right.
Is that something that integrates into someone else's like current cooling strategy, power management strategy? How does that work with, I mean, because obviously we've got a bunch of computers on tables with different solutions for keeping your rig running cool.
Right. So with iCX, I mean, basically we're able to monitor all aspects of the card and able to control each of the fans and make sure that basically all the components on the graphics card are running within acceptable temperatures, not just relying only on the GPU, because memory, VRM, they both get pretty hot.
Too, yeah.
So for us, we just want to make sure that we're developing a cooling solution that's able to cool the entire graphics card.
Yeah, so we're doing a lot of talk about temperature and cooling, and for someone who maybe is brand new to this scene and doesn't understand why this is important, can you please just from a very basic level explain to us what is overclocking and why would someone do it?
Yeah, so overclocking is essentially the act of increasing the graphics card's performance beyond what it's shipped at. And today, in 2017, it's actually really easy to do with the software that we provide. It's called EVGA Precision. There's other ways to do it as well, but Precision is one example. And cooling does play a role in that as well. As you increase the clock speeds, the voltages, the temperatures go up. So making sure that everything is running cool is very important, especially for overclocking.
And again, if someone is new to this, what would be some risks that they might want to be aware of when trying maybe for the first time?
So the great thing about overclocking today is there's actually relatively low risks overall. There's a lot of safeguards built into the graphics card and software to really prevent anything from blowing up, you know, or
That's good.
whatever you want to call it.
Like my verse overclocking experience was on an AMD T-Bird, which I did manage to melt down.
Yeah. Yeah, in the old days, when like 10, 15 years ago, I mean, yeah, you could really damage something if you didn't know what you were doing. Today, there is quite a lot of safeguards built in. The one thing that you kind of just want to keep an eye on is, again, the temperatures, making sure that everything is within safe operating temperatures. But again, the card kind of does a lot of that automatically. There's not a lot of, when it comes to cooling, I mean, it'll increase the fan speeds if it's getting too hot. So that part is, you know, you don't really need to care about that.
But really, I mean, as long as the expectation is you're putting this in a case with an adequate power supply, and you've considered the sort of the airflow or the liquid cooling solutions of the rest of the components, then the card is able to sort of manage itself.
Yeah, certainly.
When you go like, hey, hit turbo mode, you push that red button on the front of your old compact, then everything should work
for the most part. Yeah, I mean, yes, when you do increase the clock speeds and voltages, you are increasing the power as well. So you just kind of want to keep that in mind. You know, you don't want to go over your power supply limitations. However, power supplies have a lot of safeguards built in as well. So,
shut it down.
So, yeah.
We're doing a lot of talk about how easy this is. So could you actually walk us through it and show us what it would be like?
So maybe we can switch to this PC here. So what I have here is EVGA Precision. So this is a free software that you can get at evga.com/precision. So we have a few different knobs here that we can play with. Let me see if I can actually...
I love that they look like hardware sliders.
Yeah.
Come from a background of like audio mixers and control surfaces.
So actually we wanted to load up Shadow of War, which is a recent title that came out like last week or something.
Yeah, dude.
So basically, this is what it looks like when you install Precision. Out of the box, or out of the download, whatever you, I guess. Not sure what you call it. So this is basically running at default. So the first thing that we're going to do is hopefully we can load up Shadow of War here and then show you what it looks like. In the upper left-hand corner there, what you're seeing is a Precision overlay. So this is also built into the software. So it's able to show you basically all the vitals of the card in game.
What should we know about the specific graphics card in the system that we're using now?
Yeah, so the graphics card that we're using is the GTX 1080 Ti FTW3 model, which has the 3 fans and iCX technology, all that good stuff.
Cool.
So, well, let me change something here.
Again, it's a live show, guys. Doing this live.
Doing it live.
Yeah, so we are actually running a multi-cloned, dual monitored setup, so there is some kind of extra precautions that we need to consider when doing that.
Sure.
Oh, definitely. But so we were talking about increasing, you know, sort of the output or the power of this card. Just as like a general idea, what kind of performance gains or expectations might someone have with, I mean, because it's not without some risk, obviously, as many safeguards as we have kind of keep that from just blowing up in your face with how expensive these components are.
Right.
But I mean, all things being equal, just looking at the graphics card, this is enough of a tangible benefit that people seem to like doing it.
Right, yeah. I mean, I think part of the reason is it's relatively easy, you know, to overclock today. It's also free, most importantly, right?
Yeah.
So you can overclock, you can get an extra maybe, I mean, it varies from card to card, but I would say an extra 2 to 3, maybe 4% headroom. And that headroom is kind of built onto every card already. Nice. So we can actually show the demo now if you want to switch over.
Yeah.
Yeah, so again, I was saying in the upper left-hand corner, we're showing all the vitals of the card. So this is showing like all the temperatures. It's also showing my clock speeds and my frame rate in the lower left-hand corner, or actually the bottom of that list there. So you can see my GPU clock is running at 1949 megahertz. That's actually the clock speed of the card. Okay. So out of the box, this card's running at 1949. So again, let's try to do this. So what we're going to do is we're going to switch to Precision. So the first thing that I'm going to do is increase the power target here. That's this slider right here. And so what I'm doing by changing the power target is I'm not actually increasing the power consumption of the card. I'm just saying, okay, this is the maximum ceiling, power ceiling, you could say. So we are saying, if necessary, the card can pull up to 117% of the card's power. Okay. So we're going to start with the GPU clock offset. So what I'm going to do right here is set this is relatively minor, just a 15 megahertz offset. So what we're saying here is increase 15 megahertz beyond the clock speed that the card is running at out of the box. So if we go back into Shadow of War, you should see in the, takes a little second to open up here.
Live, doing it live.
So basically you can see that now I'm running at 1987 megahertz. So that's really, I mean, it's really that easy to overclock. I mean, now the card is essentially overclocked.
Now, with the stuff we were just talking about before this, virtual reality, mixed reality, how does EVGA, overclocking, and iCX fit into all of that?
Yeah, so with VR or AR, having a high level of performance is very important. I think I caught you guys saying earlier, if you don't have a high level of performance, you can actually get nauseous from not having 120 frames per second.
Right.
So overclocking becomes even more important in those situations because not only are you getting better performance, you're also not getting sick, potentially. So, so overclocking does play a role in that as well. And we kind of demonstrated it here on the 1080 FTW3, and I mean we're running at 140 frames per second, in Shadow of War. But if you have like a GTX 1060, 1070, and you're like on the edge of playability, like 30, 35 frames per second, I mean you can get another 5 frames per second and move into that playable range, or maybe increase the image quality one step higher. So.
Now, will there be any benefits for non-gaming applications trying to drive a card like this more aggressively? Yeah,
so really anything that's using the graphics card is going to get benefit from overclocking. You're running the card at a higher speed, so whether that's like video encoding, if it's actually using the GPU, then it'll encode faster. Basically anything that's using the graphics card can benefit from being overclocked.
All right, now before we jump into our deals, which we'll get to in just one moment, what can you tell us about the EVGA Power Link?
Yeah, so I actually have one here. So this is the EVGA Power Link. There's one on the system there as well. So this is a small device that basically, it's a purely cosmetic device. And what it does is it basically plugs on the side of the graphics card just like that.
Right.
And it can support a variety of different graphics cards, not even just EVGA, but a lot of different graphics cards, like a lot of the NVIDIA Founders Edition cards it's supported. And it just makes the cables look cleaner. So if you imagine your cards in your system like this, you don't have these cables, unsightly cables coming out the top. You have them basically redistributed to this lower edge. And that's really essentially the goal of the product, is to clean up the cable management, make it look nicer, possibly improve airflow in the chassis as well if there's cables blocking airflow. It could, again, support a variety of different graphics cards, whether your card has a single 8-pin or dual 8-pins or 6-pin. We include a little adapter here that you can change it to a 6-pin if you needed to. So it's pretty cool.
Yeah, we were talking last week that my workstation sort of is at the end of its life, and over the upgrades that I've given, it's a total Frankenbox.
I still haven't seen a picture
right now.
of it.
I'm going to bring one in. I promise you next week we will have a picture of Frankenbox.
We'll show it on the show, maybe.
And we will, so that everyone can mock me. But it's like, you basically just built that product for me. He was like, oh, it's totally cosmetic. And you're like, I have cable problems.
Yeah, we've seen plenty of rigs that need some cable management upgrades, so we're like, hey,
Excellent. Awesome. Well, thank you so much for running us through that demo.